Hey, it's me, Destin. Welcome back to Smarter Every Day. I want to talk about something that's really neat. I'm at Naval Air Weapons Station, China Lake here in California. I'm in front of a building that does things, and here is an F-18, which is a beautiful bird. This particular aircraft can be configured for the attack role or for a fighter role. And there's something I want to show you that's way over here. Check this out. You know, all the different weapons on the pylons. Got some bombs over there. Look at this. This is a Sidewinder missile, and this changed a lot of things, a lot of places. So this is one of the first heat-seeking missiles that was developed here in the 50s, right here, China Lake. And let's look at it. So you got a seeker up here, so it could go towards the exhaust of an aircraft. You've got some kind of pivoting fins right here, right? Look right here. You've got, this is like a side-looking proximity sensor, which is amazing that that's on this model. This is a Warhead. We'll talk more about the Warhead in a minute. You got the rocket, and then you got these things in the back. Look at this. So I want to talk about this. If you look closely, you'll notice there's something that looks like a water wheel here. You see that? Oh, it spins. Look at that. So this is called a rolleron. Now, if you can imagine, this aircraft is flying along super, super fast. You shoot this missile at Mach 2.5. You want to stabilize it, right? You don't want it to just like spin and roll. So you got roll, pitch, and yaw, right? You don't want this thing to roll in ways that you don't want it to. So this is a genius way to get around that. So a rolleron, oh look, you can see right there. You see those little bitty divots? You gotta look close. See those little things that are drilled out there? That's where they balanced it, because this could spin at over 100,000 RPM. And so they had to make some way more or less than others. So they had to like spin this thing up and balance it like you'd balance a tire by removing material. But anyway, a rolleron, what it does is as you fire the missile and this spins up, you get a flywheel effect. So you get a gyroscopic effect, and it becomes a giant flywheel, like a gyroscope. And so that angular momentum gives you an angular momentum vector that's right there. And you can see there's 4 of them. There's 1, there's 2, there's 3, and there's 4. So imagine, if you would, you're about to fire this missile, and if you have problems with dynamic stability in the roll axis because you're an engineer in the 50s and you don't have really fast control loops and digital circuitry at your disposal yet, this is just genius, because it's a passive dynamic stability method. So imagine you could pin a vector here, here, and there, and just kind of lock it in space so it'll go straight. That's amazing. One thing I don't understand is there appears to be a pivot point here. So as the missile tries to roll, this thing could try to stay in position, and so it'll try to stay back where it was. And I assume that would also provide some aerodynamic stability passively. I don't know. I don't know how that works, but I think it's fascinating. So I think it's an amazing piece of engineering. There's a newer missile, a newer version over here. That's the AIM-9 M. I think the first one, I read it on a thing. Is it on this? Okay, so the first one, so that one over there was the M. The B was the first one they deployed. This one is the X. This is the AIM-9 X. So this one right here is, if I can focus on it, let's see if I can focus up close here. So you'll notice it's different. It doesn't have pivoting blades up front. It's fixed here. So we've got a seeker. That's good. Let's move back. Don't have a proximity fuse here. This has got this kind of billet here. Warhead, rocket, brown stripe for rocket. That's where it leaves the rail. And then way back here, look at that. So these fins pivot in the back. So it's different than the 9 mic over there. This is the 9X. Also, this is just a model, but you can see anytime you have something in the rocket plume itself, that's usually an indication of thrust vector control. So I assume that means that the AIM-9X can do thrust vector control. I've never worked with the system, so I don't know. But I hear this thing is amazing. But it doesn't have rollerons. Because I just think it's clever and interesting. So rollerons are neat. And I don't know much about them. but it's a genius solution to a difficult problem. So last thing I want to talk about here is the warhead section right here. So if you can imagine, this missile is designed to engage aircraft. So you've got an engine there, the back of the engine's there. So let's say you're going for a heat signature there, and it is able to approach and acquire. It would probably lead the aircraft a little bit. I don't know how they do that, but let's say that it gets to the end game and it wants to detonate this warhead because the side-looking proximity sensor sees something. Well, this little warhead right here is called an expanding rod warhead. And the way it works is, imagine you had a little bitty rod of steel here, here, here. Maybe it's steel, maybe it's tungsten, I don't know. Sometimes people use tungsten because it's more dense, but imagine you had all these rods stacked up in a cylinder around this thing. And you were to weld this end, you'll weld two rods together, and you go to the top one, you go all the way over, and then you weld these two rods together, and you just zigzag back and forth, and you go all the way around the warhead like that. Well, what happens is, once you have those rods welded together, and you detonate the explosive on the inside of that, it would kind of scissor out. Does that make sense? Like it's a cylinder, and then it would kind of scissor out like that, and you would have like a torus, you would take a cylinder and turn it into a disc quickly, and that creates a cutter that's orthogonal to the direction of flight, which is a really bad day if you have an engine, a hot engine on an aircraft. You know, the idea is to damage the engine. So that is an amazing design, and I just thought it was interesting, and I thought it would be worth talking about. So hope you enjoyed this random discussion about a Sidewinder missile. That's it. I'm Destin. You're getting smarter every day. Have a good one. Bye. If you look hard enough on the internet, you can find your own roller-on Sidewinder missile fin. Oh my goodness. It's amazing. Check this out. Actually works. You can see they've been balanced. Yeah, check it out. This kind unlatches. So I'm gonna build something and check it out. I may have cut myself in the first 30 seconds I had it on this little part right here, but it doesn't matter because we got it. So thank you to everybody that supports on Patreon, patreon.com/SmarterEveryDay. You just bought me some missile parts. Oh yeah, front fins too. Duh. I guess it's like that. That's a front fin. How cool is that? Okay, thank you so much. Feel free to subscribe if you want to see what I do with this, because I have an idea. Anyway, thank you very much. I'm Destin. You're getting smarter every day. Have a good one.